All right, good morning, everyone, and thanks for coming. Today I'm going to talk about how PagerDuty took a public version of our API and shipped a brand new version of it without losing our minds or indeed our developers. So I'm Steve Rice. I'm a software engineer. I've worked on front-end, back-end, and lately mostly on APIs. I'm the API captain at PagerDuty in San Francisco. Insert your favorite self-deprecating American joke here. And I'm on the platform team at PagerDuty. Before I move on, I just want to note that these slides are on GitHub, so don't feel the need to frantically jot down everything in your notebook or take a bunch of photos with your smartphone. Instead, you can take some Nordic API selfies. So PagerDuty, if you're not familiar, we are an incident resolution platform. What that means is we take events coming in from all your monitoring systems, things that are monitoring your servers, your infrastructure, things like, is the website up, are people able to make successful requests, that sort of thing. Triage these events, and then notify your on-call responders about what's going on in your systems. We then help you manage the incident response process, things like getting the right people involved and providing context in order to help you resolve your incident more quickly. We are a SaaS product, so when I talk about a public API in our context, this means that our paying subscription customers are able to use the API, but it's not the sort of thing where anybody can just go and get a key and start making API requests, unless, of course, they're using a free trial. We have about 250 employees, and when we started this project, we had about half of that. And our tech stack is fairly straightforward. It's things like Rails, MySQL, Scala, Cassandra, Kafka, all these technologies that a lot of people in the space are using. We have a number of clients that we maintain. Our front end is in Backbone and Ember.js. We also have native Android and iOS apps. And having an API has always been very important for PagerDuty because we don't provide any value unless you can pump those events from your monitoring tools into the PagerDuty platform. Internally, we've been developing a lot of APIs for our microservices to be able to talk to each other, for our front ends to be able to communicate with our back ends, and so on. So it wasn't much of a stretch for us in 2012 to release the first public version of our API, where our fairly tech-savvy customer base is able to automate some of the processes, build new workflows, and do other things that aren't supported natively by the product. But this kind of API development pattern, where we're building APIs to support product features and then release them, can lead to some APIs that aren't really super fit for public consumption. Things that are very specific to a use case, have kind of esoteric parameters, or things that have weird side effects, or something that's not easily consumable by our developer audience. So last year in 2015, we decided that it was time to release a new version of our API that would kind of clean up and fix a lot of these issues that we've been seeing with our API over the years. So the first step is to research what we wanted to do with the API. And in this area, it's really important to leverage what other people are doing in the space. There's a lot of great thought that's going into how to develop APIs, how to manage APIs, how to document APIs, and especially when we're in a space where fundamentally it's about different systems communicating with each other, the more that you can use standards and existing best practices, the easier it is for these things to talk to each other. Conferences and talks are a great way to sort of get the ideas around what you might want to do with your API. So everybody here can give yourselves a pat on the back. You're one step ahead. In particular, this talk by Amber Fang of Stripe about how to move fast and don't break your API was very instrumental in helping us figure out a strategy of how to maintain multiple API versions. But it's not just these technical things. You also want to focus on how to communicate about your API, how to connect with your developer audience. And you can look at some great examples out in the space of people doing that. There are a number of protocols, Hypermedia types that you can leverage to do this sorts of things like GraphQL, things like JSON API. I'm sure you've heard about these, and it's a great way to bootstrap some of your API structure and focus more on what the application-specific parts of your API are. When you've done all this research, you need to establish a plan. And planning and design is all about making decisions. Especially with API design, which can seem on the surface to be fairly aesthetic, a lot of people are going to have a lot of different opinions about how things should look. At PagerDuty, it's been important and very useful for us to have an individual or a small group of people who are kind of anointed with the final decision-making power so that we can move forward and make progress on some of these things we want to implement rather than getting stuck in the bike shed. For us, we have a lot of open source clients that other developers have written using our API. And it's been very useful for us to go back and look at what people are doing with the API and some of the code that they're written. It really helps you get out of that headspace of your own context about knowing how your API works and seeing how people are actually consuming your API, where some of the patterns that you thought were working are breaking down, and where developers are doing a lot of work to work around things that aren't so great in your API that you could potentially fix. But as important as it is to kind of connect directly with developers, get their kind of feedback, look at what they're doing, you don't want to over-index too much on these specifics. So to keep the broader view, use your logs, use your metrics, use whatever data you have to see what endpoints people are using, what they aren't using, what might be slower in terms of performance, what people are trying to do with your API to kind of get that big picture and keep that in mind. An example for us is we have something called notification rules. This is part of a user's data. We had all these separate APIs to manage notification rules that nobody was using. So we looked at that and we said, okay, we don't need this complexity. We don't need to manage this kind of thing, and helped inform some of the patterns around this type of data that we wanted to put in the next version of our API. The result of all this was the API v2 vision. This is basically our spec describing what we're trying to do with the API, what we're not trying to do with the API, and the various patterns and things that we're going to be supporting and sticking to in the API. This living document serves as sort of a reference as we're developing and iterating on the API to figure out what we want to do with it. Now, you can't do everything, so you really need to pick your battles. And the most important thing is not to change something that's already working. Every change that you make to your existing API is something that a developer is going to have to deal with, and that's causing pain for them. So make sure that every change you make is actually providing value for your developers. And then prioritize what's most important. You're going to end up cutting things. So focus on what's going to deliver the most value first, and make that the first thing that you try to do. And we're talking about building platforms that are going to last 5, 10 years. It's really hard to get at the specific level and clairvoyantly come up with something that's going to be fine 10 years from now. But in a general sense, you can keep an eye out for the sorts of things that are going to cause performance problems down the road. If something is scaling linearly or worse with size of data or time, that's something to keep an eye on and maybe address early on. Similarly, if you have patterns that apply very specifically to a specific use case, they may not have the flexibility or the ability to change for new use cases in the future. So here are some of the things we focused on for API v2 at PagerDuty. The first was header and key-based versioning. So key-based versioning means when you create an API token, it is tied to the version of the API that was released at that time. So as we create new versions of the API, existing integrations continue to work because the keys that they're using are tied to that existing version and nothing breaks. At the same time, we allow you to specify an accept header with a version specified inside of it so that your code can be tied to a particular version of the API. And regardless of what keys you're using, if you're accepting keys from different users, you can still get the right version. We do this through a custom media type registered with the IANA. You can fill out a form and get your own. And it has a version parameter as part of its spec, so you can say what kind of version of the API you want to use. A second big focus for us was having a canonical API subdomain. So all of our customers have their own subdomain. That's how they log into the product. And initially, that's how you access the API as well. But what we found is that a lot of third-party clients would need 2 pieces of information from one of their users in order to talk to the API. Not just a token, but also the subdomain they need to connect to. So by just kind of doing some magic at the load balancer level, making it all just api.pagerduty.com, that's half the information that a developer needs in order to start talking to the API and reducing a lot of variability. We use standards wherever possible. We respect HTTP semantics. This is kind of the foundational idea of REST, utilizing HTTP methods, get, put, post, patch, and delete in the ways that they're intended, and using semantically valid HTTP status codes and responses wherever we can. In the data itself, wherever there's a standard, we try to leverage it. So this is things like ISO 8601 date times, IANA TZ info identifiers for time zones, and so on and so forth. We supported basic authentication in the first version of our API, and this is something that we wanted to deprecate. So basic authentication is essentially I can specify a username, in our case an email, and a password with a request that I'm making, and that's how I authenticate my API request. But it's never a good idea to have a user password stored somewhere. Even if it's encrypted, it's potentially and theoretically something that can be recovered. And at the same time, your hashing algorithm is intentionally slow to prevent brute force attacks. So that's a penalty that you're paying on every single API request that's being made. Some of the other performance things we had to look at is when we had paginated endpoints, we returned this total field in the response that would tell our clients how many records matched the query that they had made. What we found was that the most common use case for this was just figuring out whether there was more data available and the client should keep paginating through the result set. But it was really expensive for us to actually calculate the exact number of records that matched a query. So instead of having that total in there all the time, we provide this Boolean value more that just handles that main use case, says whether or not there are more records is far easier for us to compute. And if you still need a total, you can still get it by passing an optional parameter. Consistency was kind of the big focus across the board for us. Consistency in endpoints, in parameters, in representations of entities within the API. If you're consistent across the API, then developers who have implemented some functionality on top of it will have an easier time adding new functionality without kind of going back to the drawing board and figuring out a new pattern or a new way of doing things. Now, that plan I mentioned earlier is definitely a living document, and you want to build the idea of change into your process. As you're working on the API, as you're developing it, you're going to have smart people who say, hey, this pattern that we thought was going to work doesn't really make sense. We're having a hard time implementing this endpoint in this way, that sort of thing. So if you can revisit this over time, it's going to make your API a lot better than trying to set something in stone and always stick to that. This kind of process is really important to what you're doing with your API. We had initially this process where if somebody wanted to make an API change, they would write an email to an email list, people would comment on it, and then the API czar would kind of come down and make the final decision about what we're going to do. It's really difficult, though, to have this kind of context in email because it's something that people have to keep bringing up over and over. It's not clear how things are progressing. So instead, we moved to a GitHub-based model where people can use all that great functionality of GitHub pull requests, like code reviews, inline comments, and version history, so you can see how the proposal has evolved over time. Another few things we experimented with, one is this little bot we call Flagger. It just it knows something about our code base, looks at pull requests that are making changes to it. If something looks like it might be an API change, it just puts a little label on it to tell the developer who's making that change, hey, by the way, this looks like an API change. Keep in mind, this might need some API review in order to just kind of keep the process moving. These little things that keep this all at the top of developers' minds are really key to preventing things from going around the process or otherwise slipping through. Now, documentation was a big focus for us. And the most important thing with documentation is to maintain it well. If you have documentation that describes one thing to do, a developer implements that, and then tries to make an API request and gets an error, that's extremely frustrating. At the same time, if you have functionality in your API that isn't in your documentation, people don't know about it and they don't know how to use it. So your API is only as good as your docs. We originally had this sort of thing where we had a bunch of different HTML templates that all got cobbled together into the final API documentation. It was mostly a mess, very hard to maintain, the sort of thing where we'd end up with one version of something on one part of the site saying how to perform an action, and then something completely different on a different part of the site saying something else about the same action. We're very lucky in this space to have some great domain-specific technologies for doing this. Spec formats like API Blueprint, Open API Spec, or Swagger, and RAML really help with this, and you should definitely be using them. We use Swagger. As we developed our Swagger spec, it ended up being the largest Swagger spec that we had seen at the time, and we ran into a bunch of issues with some of the community-supported tooling where we would try to import our Swagger spec and get all sorts of 500s and things just crashing. So we developed a number of tools internally to kind of manage this better, namely being able to separate out the spec into individual parameters, endpoints, definitions, that sort of thing, so developers could work on them individually without clobbering all over each other. And remember that your documentation is for humans, so make it human-friendly and human-first. Stripe's API documentation has always been a standard bearer in the space of being really clean, really straightforward, really concise, and telling people straight away what they need to do and how to access the API. And one of the great things that they do is have a lot of different code samples so that without writing code, developers can sort of start talking to the API. It's really important to reduce that friction so that a developer can come to your API, start using it, get a sense of how it works and what they can do with it without having to invest in what libraries they're going to use, what language they're going to use, bootstrapping their environment, and to start writing that code. So we used a fork of Swagger UI to give us some interactive documentation in the browser where developers can just go and make API requests straight from there. Something else that you're able to do is provide these code samples or these SDKs. Now keep in mind who your audience is. A lot of people are going to be coming from your existing version of the API, so don't make them kind of manually diff through and figure out what's changed. Give them a concise summary of what's new, what they need to be concerned about, and what are the other things that they can do with the API now. When you're developing the API, the best thing you can do is just keep it simple. Shane at Airbnb yesterday talked a little bit about Graphist, a gem that they developed internally to sort of manage some of this process. We did something similar with a gem we called PagerDuty. It kind of lets you process some of the requests, validate that the things you need are there, and then normalize it into something that can be used internally to implement the business logic and return a response. In addition, we wanted to keep our API v2 basically to start off performing exactly the same way as v1. So we just used inheritance, which is a very simple tool to do this, to kind of inherit all the same behavior. There were some downfalls here in that there are some other semantic meanings to that, and developers, as they do, are trying to kind of avoid code duplication and that sort of thing, which led to sometimes it being pretty hard to reason about how the API was working. So keep this in mind and don't be afraid to copy some things or be a little bit more pragmatic so that it's easy to understand what's going on. Testing is super important, and nothing more so than dog fooding. You can automate all your testing. It'll help you catch bugs and things like that. But unless you're using your own API, you're not going to be aware of issues like, this was really hard to implement, or this pattern doesn't make a lot of sense, or there's something that we could be doing better here. When we started our development process, since our APIs did work exactly the same way, we switched all of our clients to the new version. And then instead of having sort of this big integration point at the end where we need to test everything, we could incrementally make changes and immediately implement them in the clients to figure out if they were working, if they made sense, and if there was a change we needed to make. Automated testing is also important. There are some great tools to do this. If you have a spec, it's even easier. Manual testing is still valuable in terms of testing for regressions, doing some smoke testing. We had some simple tools that would comb through our logs, find the most popular API requests, test a change in staging before and after, and make sure there were no differences. You're going to have to connect with your developers, both internal and external. At PagerDuty, we have an internal conference called PagerCon, which is a great way to evangelize some of these API principles with internal developers, get them thinking about our API vision and our values. And you want to repeat this message over and over, not only for new developers who are just joining and who may not have heard it before, but also to keep this top of mind so that when developers are working day to day on specific implementation details, they have that broader context in mind and they know what we're trying to achieve. Of course, you want to reach out to your external developers too. Every time you're making a change, especially if you're deprecating something or anything they need to know about, just over-communicate. The worst thing that happens is it ends up in somebody's spam box. The best thing that happens is you hear early about something that you didn't anticipate, that you still have time to make a change and respond to before it's too late. Have a beta program and provide incentive for developers to use your beta. Whether it's new features, enhanced performance, anything like that, this will help you catch bugs early and also get that sort of early feedback that allow you to respond to things that you need to. When you're launching, market your API. This is our original developer portal for the first version of the API. Here's what it looks like now. You can see that all the reference information is still available, but primarily we're using this as a funnel to get people on the new version of the API, which we think is better for us and for them as well. And it's really hard to capture the value of your API in some sort of rote, dry documentation. So demonstrate what your API is able to do. Things like webinars, demos at conferences, that sort of thing can really help people understand what your API is capable of. And keep an eye on your metrics. You want to know what your adoption is like so you can respond to that if you need to. We launched the second version of our API in June of this year, and we've been very happy with the uptake so far. So what's next for PagerDuty and APIs? Well, we're not really in the business of maintaining a whole bunch of different API versions. That's not our core value. So we do want to deprecate the first version of the API and get people onto the new one. So we have an internal plan for this. And the most important thing here is just to be able to adapt and change that plan if we need to. We're interested in backends for front ends. This is something that's kind of coming up new in the space. Allows you to do things that are a little more client heavy if you control the clients, like GraphQL, like client authorization, like HTTP2. And our API is just a part of our larger platform strategy. When we're talking about platforms, it's not just about having one API, it's about having multiple APIs for different ways to talk, webhooks, ways for people to write code and execute it within the platform, to add UI functionality into the platform, sort of this whole coherent experience of here's how I can build additional value onto the product, onto the platform for me and for others. It took about 8 months for us to complete this project of focused development time with a team of about 3 or 4, plus a few months of planning and, of course, a lot of communication and follow-up. And like everything, it takes a village to do a project like this, and here are some of the fine folks at PagerDuty that helped us make this a reality. Is this the end? No, of course not. Developing a platform and developing an API is a continuous, ongoing process. You always need to be aware of what's new in the space, how you can improve, how you can continue making a better experience for your customers. If you want to learn more, go to developer.pagerduty.com. That's our developer portal that talks about everything platform at PagerDuty. I think we have a Q&A section next, so happy to answer any questions. Or you can find me offline. I'd love to chat about anything APIs. Thanks.
Thanks, Steve.